Okay, so let's do the last question that I'm going to make a video for today, which is this lovely coordinate geometry question, which is worth 7 marks and has got very little to it in the instruction for the question. But what I'm going to say to you is, for coordinate geometry questions, if they don't give you a diagram, then just sketch up yourself a really quick one. So for example here, if I just quickly draw myself sort of a graph of the situation, I've got the point -1, 3, which is kind of over here somewhere. That's my point -1, 3. I've got this equation which is 3y plus 2x equals 33. And I can graph this by using the x and the y-intercept. So down here on the x-axis, we know that it's going to cut the x-axis when y is 0. So if I make y 0 here, I'm going to get 2x equals 33. So then x is going to be 33 over 2. So I can just draw it there. This is not going to be the scale, so just to give you an idea what we're looking at. And then for the y-axis, we know that x will be 0. So if I put x equals 0 in here, 2 times 0 will be 0. So 3y equals 33, so y is going to be 11. So let's put that up there, let's say. And then that's our line there. How do you find this point reflected across this line? Well, if I just quickly draw for you a mirror line like this down here, let's call it K as a mirror line. If I've got a point sitting here, how do you reflect it across the mirror line? Well, you find out here how far away it is from the mirror line, and then you do the same distance over to get the other point on the other side. The important thing about this is that whenever I teach like reflection, I always tell students to rotate the mirror line around so it's looking vertical like this, and then it's easier to see the distances as like a perpendicular to the mirror line. So we're going to do the same thing for this line here, and let's see if it's going to work. Oh, there we go, look, see? What I'm going to do, this is so much fun, is I'm going to imagine doing a perpendicular line across like so, and then I'm going to use that to work out this point R that we're after over here. Now, this doesn't go through that point there. I haven't drawn my diagram to scale, remember, so this is just a coincidence. It looks like it's there, but it's not. So to solve this question, I have to find the equation of this perpendicular, which is all good because I know it's going to have an opposite, gradient to this line here. I've got the point on the line, so I can use that to find an equation. Then I'm going to find the intersection between the perpendicular and the original line. And then all I'm going to do, if I just turn it back around again now, if I turn it back around, like so, so fun. And then all I'm going to do after I've found that is work out how far over and how far up to that point, and then use that same translation vector to go across and up to find that point. Cool. So those are our steps. So let's do it. So the first step we have to do is find the equation of that perpendicular. So we need to know what the gradient is of the white line to begin with. So if we go back to the original equation, we know that 3y plus 2x equals 33. So if we rearrange that into y equals mx plus c form, we get 3y equals negative 2x plus 33, so then y equals negative 2/3 x plus 11. Cool, so then our gradient of the white line is negative 2/3. The gradient that we want is going to be the reciprocal of that, plus the sign will be changed. So we want the gradient to be 3/2, which is a positive gradient, which makes sense with what we can see visually here. Okay, so that's cool. So we need an equation that goes with this pink line. We get that using the formula mx minus x1 equals y minus y1. In this case, our m is 3/2. 1 point on the line is -1 for x, and our y value on the line is 3. And because we're going to use this to solve an equation, we do want to tidy it up a little bit so that we can use it. So if we expand that out, inside the bracket is going to be x plus 1. So when we expand that out, we're going to get 3 over 2x plus 3 over 2 equals y minus 3. And if we write that in y equals mx plus c form, we're going to get y equals 3 over 2x, what is that, plus 9 over 2. Cool, so that's the first thing we had to do. The next thing we have to do now is to find where this line intersects, this perpendicular intersects the original white line, so that we can get this point here. So it's going to be a simultaneous equation. So we've got this equation here, we could use it in this form, and we've got this equation here. You could do two sort of different methods. You could either use substitutions. You could substitute this into the original equation here, or you could equate these two together. It's kind of up to you. What do I feel like doing? Let's equate the equations. Why not? I'm just going to make some space so we can do this. Hold on. Get rid of that. Oh, I got rid of the line at the same time. Didn't mean to. Put the line back on there. Right. Okay, so let's equate those two equations. So we've got negative 2/3 x plus 11. Let's equate that with 3 over 2x plus 9 over 2. Oops, that should be a 9. I'm going to multiply everything by 6 so that I can not have those fractions, just to make it a little bit easy for ourselves. So if I multiply everything by 6, the first term, when I multiply that by 6, I'm going to get negative 4x plus 66. And then if I multiply this term by 6, I'm going to get 9x. And the last term by 6, I'm going to get 27. And if I group the x's together and the numbers together and solve that, I'm going to get 13x equals 39. Okay, so x equals 3. To get the y value at that point, I can use either of the equations to do that. So let's say we put it into this equation here. If I put x equals 3 into here, I'm going to get negative 2 plus 11, so that's going to give me 9. Cool. So what I know now is at this point here, they cross over at the point 39. So you can see my diagram is completely not to scale because that doesn't look at all like 39. It's just to help you visualize it. That's why they say find by calculation. They don't actually want you to draw it and actually read it off the diagram. It's just to help you imagine what it looks like. Cool. So now we know that point, we can use a translation vector to get point R. So how that works is we just have to go back to this diagram here and look at how far across does it move from negative 1 to get to 3. Well, it moves across by 4. And how far up does it move to get from 3 to 9? It moves up by 6. So if we apply the same translation vector, and so again we go across by 4, and then we go across by 4, that's going to take us to 7. And so if we go across from 4 from 3, right? And then if we go up another 6 from 9, we're going to get to 15. So that's our point R. There, that point R there is the point 7, 15.